Okay, 3.2 is on synthetic division. Now, this section is not a mere testing section, but this section is going to be showing you the method that we're going to use to work the problems in 3.3. Okay, so this is pure is really just a method that I would like for you to use to work the problems in the next section. So synthetic, is a false form of division. This type of division is kind of like the shorthand. It does not include the variables to actually do the division part. We add the variables back in the end to write the new polynomial. So let's look at a couple division problems to show this method. If you were to have x to the fourth plus 5x to the third plus 4x squared minus 3x plus 9 divided by x plus 3. Now, I want to know if x plus 3 is one of the factors of this top polynomial. Now, you might say, wow, that's a long polynomial, but it's a fourth degree, and I'm going to circle that. Fourth degree meaning that there are 4 answers. This is what's leading us to 3.3. In 3.3, which is titled Zeros of Polynomials, we have to find all of the answers that would break this down, that would divide into that polynomial. So this particular problem has 4 answers, okay? Now, in 3.2, I'm just going to show the synthetic division on how we're going to find these answers in the next section. Now, I want to know if x plus 3 is one of the factor forms of the 4 answers. So I'm wanting to know if negative 3 is an answer. Now, make sure you are listening to what I'm saying. X plus 3 is the factor form. You know, when we have factor forms, we set them to 0 to find the actual number. So the number that I'm trying to see if it's an answer is negative 3. It's the opposite, okay? So when I do my synthetic division, you're going to check negative 3 to see if it's an answer, okay? Now, looking at that top polynomial, you should be in descending order in accordance to your exponents. So we go from fourth to 3 to second to first to no exponent. So we are in descending order, and I'm not missing a term. If I was missing a term, I would need to substitute a 0 as a holding spot for that missing term. So I'm not missing a term. I go from fourth degree to third degree to second degree to understood 1 degree to no degree because there's no x on the last term. So I am in descending order. Now, I'm going to write the coefficients. Coefficients are the numbers that's in front of the x. I'm going to write them beside the negative 3 in this house to show my synthetic division. Now, we know there's an understood 1 in front of the x to the fourth term. There's positive 5 in front of x to the third, positive 4 in front of x squared, negative 3 in front of x, and positive 9 at the end. Those are my coefficients. I'm going to write those out beside my negative 3 that's considered to be in the house. And you do take the signs with it. Now, I'm going to leave some room because I'm going to write some numbers above that black line. And I'm going to do a down arrow for the first coefficient. Means you always bring it down. Now, like I said, this is a shorthand division. So please watch. You're going to multiply that starting number of 1 with the house number. You're going to multiply negative 3 times 1. That would give you a negative 3. You see I wrote it above the line under the next coefficient. Now, everything above the line, you're going to add or subtract depending on the signs. So I'm going to say 5 minus 3, which will give me a 2. Everything below the line, you're going to multiply by the house. So 2 times negative 3 will give me negative 6. And I write it above the line under the next coefficient. So then I subtract 4 minus 6 is a negative 2. And then I multiply. Negative 3 times negative 2 is positive 6. Subtract negative 3 plus 6 is a positive 3. Then I multiply. 3 times negative 3 is negative 9. And then 9 minus 9 is 0. Now, you're done because you have no more coefficient numbers. Now, this last column is considered your remainder column. Remember that from long division? Now, if you end in a 0, that means that it divided evenly, okay? So x plus 3 is a factor, meaning that negative 3 is one of those 4 answers, okay? It divided evenly. Now, you need to know this method for 3.3 because you're going to want all of your problems, you're going to be looking for them to end in 0. That means that that particular number that you divided by works, okay? Now, in this section, you need to be able to write the new polynomial after you have divided. Now, once you divide something, you decrease it by 1 degree, meaning I started with 4th degree. So once I have divided this row, would be the coefficients starting with the 3rd degree, okay? You started in 4th degree. Once you divide, we're in 3rd degree. So these numbers, 1, 2, negative 2, and 3, would be your coefficients and constant starting with the polynomial at x to the 3rd. Now we're going to add the variables back and we're going to walk them down until they disappear. So this polynomial would begin with 1 x to the 3rd plus 2 x squared minus 2x. Now you see I was going in descending order. 3, 2, 1. Now after 1st degree you don't have no more x's. That plus 3 is your constant. So the new polynomial after you have divided is going to be x to the 3rd plus 2x squared minus 2x plus 3. Like I said, this is shorthand synthetic division. Let's look at another one. X to the 4th plus 4x to the 3rd plus 2x squared plus 9x plus 4 divided by x plus 4. So again, we're dividing to see if x plus 4 is one of the factors of the top polynomial. Keep in mind, this is the factor form. Okay? So we're really seeing if negative 4 is one of the 4 answers. And you know this thing has 4 actual answers. Now, we're not looking for all 4 answers in this section. I'm just showing you how we would divide to find the answers. So we're going to put -4 in the house because that's what you're dividing. That's the number you're seeing if it's an actual zero, if it's an actual answer. You'll hear that term a lot, zero. Zero means it zeroes it out, okay? So we're going to look at our top polynomial. Make sure we're in descending order and not missing a term. 4th degree, 3rd degree, 2nd degree, 1st degree, and 0 degree. So we're good. We're going to write the coefficients, which would be the numbers in front of the x, out beside our -4. So we have 1, 4, 2, 9, and 4. And we're going to skip some space. And we're going to bring down that very first coefficient of 1. So we're going to multiply. 1 times -4 would be -4. And we write it under the second coefficient. Subtract 4 minus 4 is 0. Multiply 0 times -4 is 0. And we're going to add 2 plus 0 is 2. Multiply 2 times -4 is -8. 9 minus 8 is 1. 1 times -4 is -4. And 4 minus 4 is 0. So again, this is considered your remainder column, and it's 0. So it does divide evenly. -4 is one of the answers to the top polynomial. But let's write our new polynomial. These are the coefficients and constants for it. We started in the 4th degree. So we have decreased it 1 degree. That means that this row would start off with x to the 3rd. So that would be 1x to the 3rd. Now you don't have to write that under. That's an understood one, but I want to show you that's what would actually be in the front. Now you see you have a 0. Now don't write 0x squared. That means that that term does not exist. It's not there. So you can skip it. Plus 2x. We're done with our x's. Plus 1. So technically that polynomial would be x to the 3rd plus 2x plus 1. And that's what I would want you to write. You don't need to put 0x squared. That means that that term is not there. So it's gone. So you would go ahead and put the x term. That would be our new polynomial after we have done synthetic division. Let's look at another one. X to the 6th minus 3x to the 4th plus 2x to the 3rd minus 6x squared minus 5x plus 3 divided by x plus 2. So this polynomial has 6 answers that would work, okay? Now, we're dividing by x plus 2, which again, just reiterating that that's the factor form. So the actual number that we're seeing works is -2. It's always the opposite from factor form. Now, if you notice your top polynomial, you are missing a 5th degree term. You go from 6 to 4. You're missing the 5th degree. Okay? So you're going to have to remember when I list my coefficients, I have to have a 0 in that place. So let's do that. We have a 1. That's in front of my x to the 6. 0 for that missing 5th degree term. Then I have negative 3 on my 4th degree term, positive 2 on my 3rd degree, negative 6 on my 2nd, negative 5 on my 1st, and positive 3 is my coefficient. And we bring down that first coefficient of 1. And we're going to multiply. Your start is by multiplying. So negative 2 times 1 is negative 2. Plus 0 is still negative 2. Negative 2 times negative 2 is a positive 4. Negative 3 plus 4 is positive 1. Multiply. Negative 2 times 1 is negative 2. Plus 2 is 0. 0 times negative 2 is 0. Minus 6 is negative 6. Negative 6 times negative 2 is positive 12. 12 minus 5 is 7. 7 times negative 2 is negative 14. Plus 3 is a negative 11. So this time, you actually have a remainder. So it does not divide evenly. It did not end in 0. It ended in negative 11. So that means that negative 2 is not an answer. It doesn't divide evenly. It's not one of my 6 numbers that would work. So if we were in 3-3, you would move on and try another number to see if it would work. This would be null and void. But in this section, I still want to show you how you would write the new polynomial since we have an actual remainder. Okay? So, again, we have decreased it. We started in the 6th degree. So this row would be our 5th degree. Okay? Leading with the 5th degree. So this would be 1x to the 5th. Walk it down. Minus 2x to the 4th. Plus 1x squared. Now we know that our squared term is gone because that's 0. It's gone. Minus 6x plus 7. Now, this is how you would write that remainder. And I'm going to have to do a little erasing so you can see me write that remainder. Now, we know that the remainder is negative 11. So you would say minus 11 over, what's the factor form that we divided by? X plus 2. And that would be our new polynomial. I know it looks long, but it's a 5th degree. So we simply still walk down our variables, but this is how you would write that remainder. Whatever the number is, you would put it over the factor form. Okay. Let's look at another one. X to the 5th plus 3x to the 4th plus 2x to the 3rd plus 2x squared plus 3x plus 1 over x plus 2. So this polynomial has 5 answers, and our factor form is x plus 2. So the number that we're checking to see if it works is -2. Keep in mind it's the opposite. And we're going to look at the top polynomial. And we go from fifth to fourth to third to second to first to 0. So we're not missing any terms. So those coefficients will be 1, 3, 2, 2, 3, and 1. Bring down that first coefficient of 1. And we're going to multiply. -2 times 1 is -2. Plus 3 is 1. Times -2 is -2. Plus 2 is 0. 0 times -2 is 0. Plus 2 is 2. 2 times -2 is -4. Plus 3 is -1. Times -2 is 2. Plus 1 is 3. And again, we have a remainder of 3. So to write that new polynomial, we were in 5th degree. So this would start 4th degree. So we're going to walk it down. X to the 4th, and you can put that 1 in front. Plus x to the 3rd, you can put that 1 in front. Now I'm really going to skip over this. This is x squared. We don't have an x squared term. Plus 2x minus 1, we're through with x's, and we're going to say plus 3 over x plus 2. That's our factor form for -2. And that would be our new polynomial. Like I said, this is a shorthand division. And you'll see how I use this division in 3-3. But I want to show you how we need to get to that new polynomial by doing the synthetic division. I'm going to show you another way that you'll see it written more so on example 5. Let me show you. Let's look at it. Let's look at one more example. Now the first 4, they're in division form. You won't see division form in 3-3. You'll see it more in function form, like number 5. F of x equals x to the 3rd minus 3x to the 2nd plus 4x minus 4. And you'll see k equals 2. On some problems, now all of them not going to have a k, but in 3-2, they're going to ask you, is k an actual answer? Okay? K represents what we call zeros of polynomials, which means it's an actual factor of that polynomial. But right now, we're trying to see if it's a factor, okay? When we get in 3-3 and I give you k's, that's a help. I've helped you start the problem, okay? But right now, just a yes or no. This would be in 3-2. Does 2 work, okay? So to do it synthetic division, you're going to take 2. And you're just going to use it as is. There's no change in the signs because this is not a factor form. This is K himself. So you use the number. It's 2. And we're going to make sure we are in descending order and not missing a term. So 3, 2, 1, and 0. So we're good. So those coefficients will be 1, -3, +4, and -4. Multiply 2 times 1 is 2. -3 plus 2 is -1. -1 times 2 is -2. Plus 4 is 2. Times 2 is 4. Minus 4 is 0. So we're back with this remainder. That's 0. So that means it works. 2 is a factor. Anytime you get a 0 in that last column, that means it divides evenly. So in this section, you would say yes. Yes, 2 is a true K because it divided evenly. Now, you could also take 2 and plug it into X. And that would be a quick way to check numbers. And you can plug that straight in your calculator. If you want to know if 2 is going to work, and that would be what you might want to do on the next section. Now, I need synthetic division to get me to the next polynomial. So make sure you understand synthetic division is not a waste, but it is needed to give me this sentence, okay? But if you want to just check to see if the number works, you can plug it in for X. Now, what you're trying to get it to equal is 0. Keep in mind, all of this, you're trying to see what's going to give you that remainder of 0. If you plug it in and you get a 3, then that means you had a remainder of 3. That means it does not divide evenly. So if you plug this in, and we can do it right quick in the calculator. We know that 2 to the third would give you 8. 2 squared is 4 times negative 3 would give me a negative 12 plus 8 minus 4. So you're looking at 8 minus 12 plus 8 minus 4 will equal 0 if you type all that in your calculator. So yes, that's going to be an answer. So I wanted to show you this form, which is our known function form. This is how you'll see the problems in 3-3. They won't be a polynomial on top of a binomial. You'll see it in an actual f of x form. Okay, so I've given you 5 good examples on synthetic division, and next we'll talk about zeros of polynomials in 3-3.